This is 2009 FRQ number 1 calculator portion. All right, so here is a graph provided for us, and let's see. Karen rides her bicycle along a straight road from home to school, starting at home at time t equals 0 minutes and arriving at school at time t equals 12 minutes. All right, so 0 minutes to 12 minutes. During the time interval between 0 to 12 minutes, her velocity v of t in miles per minute is modeled by a piecewise linear function whose graph is shown above. So this is a graph of the velocity. This is not the graph of her position in this whole trip. So it's recording how fast she is going at each minute, right? All right, so where it says find the acceleration of Karen's bicycle at time t equals 7.5 minutes, indicate units of measure. Because this is already velocity, to find the acceleration, we want the slope at 7.5. So 7.5 is around here. Because it's a linear function, you simply find the slope between those 2 points. So you simply take y2 minus y1 over x2 minus x1 to find the slope at that point. All right, so for part A, we go the acceleration at 7.5 is equal to, well, y2, that's 0.2, minus y1, 0.3, over x2, that's 8 seconds, minus 7 seconds. So it's negative 0.1 over 1. So acceleration is negative 0.1. Well, let's see, how far is she going from miles per minute? So because it's acceleration, miles per minute or miles per minute squared, right? And that's it for part A. Okay, part B, using the correct units, explain the meaning of the integral from 0 to 12 of the absolute value of velocity in terms of Carmen's trip. Find the value of the absolute value. So why is the absolute value important? Without the absolute value, it simply asks you for displacement, meaning what is the difference between the beginning and at the end, right? So that means the part that's underneath the x-axis is going to remain negative, and so these two parts are actually going to cancel out because you can see they're exactly the same. But with the absolute value, what it's really asking you is how much is the total distance traveled by this girl. So now we got to force our negative area to be positive. So a quicker solution would be to take this and double it. So it forces it to be on the top. And so you get 2 pieces of this plus this last piece. All right. So we want to figure out our answer first. The absolute value of 0 to 12, the integral of from 0 to 12 of the absolute value of v of t is equal to the total distance. Again, the absolute value makes it the total distance traveled after 12 minutes, right? Because the whole trip took 12 minutes from 0 to 12. Okay, so how do you figure that out? Well, geometry, right? Let's take a look at the shapes here. We have 2 triangles, so 2 triangles times 1/2, base is 2, times the height of 0.2, right, plus for the next piece, I'm going to have to do a lot of cutting because it's not a very standard shape for geometry. So I'm going to look at this triangle first, this piece right here. So plus 1/2, the base of 1, times the height of 0.3, plus, here's a rectangle here. So that's just 1 times 0.3, base times height. And then here I have a trapezoid, or you can do triangle and rectangle, up to you. But I'm going to do the trapezoid. So plus 1/2 base 1 and base 2. So base 1 plus base 2 times the height of 8 and 7, between 8 and 7, that's 1. And then plus this big, nice rectangle of the base of 3 times the height of 0.2. And last but not least, you have a little triangle here. So 1/2 base of 1 times the height of 0.2. All right. Again, not wasting your time, but you do all the math here. The answer should give you 1.8 miles. So that means that she traveled a total of 1.8 miles in the 12 minutes. Okay. All right. Shortly after leaving home, Karen realized she left her calculus homework at home, and then she returns to get it. At what time does she turn around to go back home? Right. So any area above the x-axis is traveling away from your origin, your point of origin. So here she's traveling away from it, right? She has increase in speed and a decrease in speed, and then she turned around here because At this point, she went from a positive velocity to a negative velocity. When the signs change, that means there's a change in direction. So that's when she turned around. And then she traveled the same amount back. So you see how she traveled away and she traveled the same amount back. So she actually got home at t equals 4, right? Because that's the exact same amount as what she left to what she came back to, all right? So I would mention the fact that she turned around. So part C, she turned around at t equals 2 minutes because v of t changed signs, right? V of t was greater than 0 before t equals 2, and v of t is now less than 0, so it's negative now after t equals 2, right? So the change from positive to negative, that's how you just explain why this is true. This is a reason for your answer. And in fact, I don't know if this is necessary, but you can definitely talk about that. She reached home. It's kind of important for the next piece. At t equals 4. So really, she started her trip again right here at t equals 5 because she spent about a minute at home getting whatever she needed to get, and then she started her trip again. Okay. Last part D. Larry also rides his bike along a straight road from home to school in 12 minutes. His velocity is modeled by the function w, given by w of t equals pi over 15 sine of pi over 12t, where wt is in miles per minute between 0 to 12 minutes. Who lived closer, Karen or Larry? Show the work that leads to your answer. So Larry didn't go back home. Larry just went straight to school. So we could just very simply, for Larry's distance, you just go take the integral between 0 to 12, right? Because that's the total distance that he traveled in that time, 12 minutes. And his function here, right? And just plug in the calculator. This is the calculator portion of our AP test, right? Of our FRQ. So let's go ahead and put it in. So math 9, let's see if this is a little clearer. Okay, my function, pi over 15 sine of pi over 12 x, close your parentheses, comma x, comma 0, comma 12, close my parentheses, and let's see how far does Larry live. Oh, Larry lives a beautiful exact 1.6 miles away. So 1.6. So Larry lives 1.6 miles away. All right. Now, how far does Karen live? So we cannot use our answer for part C because for part B, because remember in part B we took the fact that she rode away and then she came back. We added these two distances together along with this distance. What you really want, if you want to calculate how far she lives from school, is really the time that she left here from 5 minutes to 12 minutes, because this is the part where she went away and then came back. It doesn't count, right? She's at home at this point. Now from this point to there, that's the distance to school. You could do that. You could recalculate this area, or you can look at this and say, well, this piece up here, if I look at my work from part B, is this first triangle here. So this first triangle, I can do a really quick calculation and see that it's just really 2 times 0.2, which is 0.4. So if I subtract this piece and subtract this piece, I'll get the piece I want. So I take my total distance of 1.8 minus 0.4 because I'm subtracting the 2 triangles here. So she lives 1.4 miles away. This is Karen lives 1.4 miles away. So now it's very clear to us who lives closer. Karen lives closer. And that's it.